Welcome everyone to our physical prototyping webinar. We are going to be your hosts today. My name is Biomika. I competed in Conrad Challenge in the 2019 to 2020 Conrad year. So unfortunately 4 years ago. I feel so old. I'm currently a junior in college. I go to school at Georgetown University in Washington, D.C., and I'm majoring in psychology. Back when I competed in the cyber tech and security category. That was my junior year of high school. Yeah, I think that's pretty much everything I could tell you about myself. And Umang, I'll let you introduce yourself as well.
Yeah, my name is Umang. I competed with Yamik on the same team back in 2019, so it's also been 4 years for me. I'm now a student at University of Maryland studying computer science. Yeah.
Cool. Okay, so this is our rough table of contents. We'll just jump right in.
Yeah, so we'll start by talking about why prototyping, why is prototyping important. So prototyping really allows you to test your solution and kind of work towards what your final product is going to look like. So it helps you kind of understand. And so it's basically the easiest way you can build evidence that supports why you're worth investing in by showing a physical thing that works to solve the problem that you're trying to solve with real users. So here's the prototyping cycle that in general you guys should follow. You're gonna have your idea at first. You should spend a lot of time designing it, sketching it, thinking about requirements that you have for this problem and the solution. And then you're gonna do a lot of testing, learn from the tests that you do, and then improve, and then reiterate. Right? Basically, you're gonna find some problems, things that didn't work, and then you're gonna have ideas for that, and you're gonna keep going through this cycle over and over again. And it's really important that you go through this cycle quickly and you plan to be okay, I'm going to produce something really quickly. It's going to fail. I'm going to make the next thing really fast right after that. And so going through the cycle multiple times is the best way to be successful in creating the best possible prototype that you can.
Exactly. So we talked about a lot of vocabulary in our little brief introduction. We'll dive into that a little bit more in the next couple of slides so that you guys, when you are prototyping, are doing it like a real inventor would. So just to start off with, when you're talking about a prototype, you want to think about it as testing a hypothesis. Now, I'm sure most of you are somewhat familiar with the scientific method. You've learned about it in some of your classes, and that's kind of what a prototype is like. Every time you create a prototype, you are essentially testing a hypothesis of, will this prototype solve your problem or not? So you're thinking about where is this prototype going to break? What are you unsure about? And how does it work towards the end goal of what you want your product to achieve? That's kind of a very broad purpose of what the prototype should be like. So getting into that vocabulary, Umang mentioned iterations. So an iteration, generally when people are prototyping, every successive prototype will be referred to as an iteration of the prototype. It's really important to have multiple iterations. You really should not be expecting yourself to get your prototype correct or functional on the very first try, because that is so rare. And even if you come up with something really good on the first try, kind of multiple trials I'm trying to say this without using the word iteration, but multiple rounds of prototyping can only make your product better. And it's really important to do these multiple tests because if you fail the first time, it'll only make your product better every successive time. And each time you can kind of refine your design. You can make small changes to make it better, a little bit more effective, a little bit more efficient. And overall, that leads to your final prototype being the best possible quality you can come up with. Additionally, you want a user-centric approach. So maybe you come up with a prototype the first round that is functional, but doesn't maybe work the best for the actual user of your product. And so again, those small changes you can make to make every iteration more successful. And then finally, it's also important for risk reduction, because with every prototype, there is some level of risk. There are things that can go wrong. And every time you kind of go through the process again, that risk will decrease because you'll get better at what you're doing. And iterations are basically very important. This is kind of just to say, starting off the bat, before you even get into prototyping, be prepared to go through multiple rounds and don't feel disheartened if your first or even second or third prototype isn't to the level that you'd want it to be at.
So the next thing that we need to talk about is fidelity, which is basically the idea is how complicated or how fancy are you going to make your prototype. So you can have a low fidelity prototype, a mid fidelity, a high fidelity prototype. you want to start by doing like a lot of low fidelity prototypes, because you just want to like test like very basic idea and see like what does it look like, will this work type of thing. So you don't want to spend like trying to make it super nice and fancy and intricate. That can be like what your final, once you know exactly every detail what this prototype looks like and you've like done some testing on like, yes, this works, that's when you're going for like a high fidelity prototype. Otherwise, like for the most part, you're aiming for like a low to mid-level fidelity prototype for the most part of like your design process. Some of the factors that you should consider while you're prototyping, like figuring out like what to use and like what to do, are like um fidelity. Again, like you're going for the low fidelity prototype, you're not going for anything fancy. How much time is it going to take to like build like this prototype that you're thinking of, with the different tasks and requirements that you might be thinking of for the specific prototype? How precise do you need to be, like in a prototype where you're just kind of like trying to see like, okay, like can this hold I don't know, like this much weight or whatever. Like you don't need to like worry about if every like single detail is very precise and exact to what you want it to be. Budget, like you don't want to spend a lot of money when you're just trying to like see for the first time if it works. Again, like all of these things, like as you get further and further along into like knowing exactly what it looks like, that's when you want to spend more time, more effort, more precision on like all of these things. And until then, like you don't really want to like, you want to use like recycled parts, like things that like you can just like quickly put together and like can break in like 2 seconds if they need to, but you just get the job done.
So here we have a little diagram, which is our axis of prototyping methods. So all of these different things on the screen that you see are resources you can use to create your prototype, and they're put on a scale from easy to difficult. Now, this scale is going to look different for every single person. Me personally, I'm like a university student, and my university doesn't have any kind of makerspace really. So for me, that university or high school makerspace is a lot more difficult to access. Uman goes to school at UMD, and UMD is much more of a tech school than Georgetown is. So they have a makerspace. And for him, that's like a really easy resource for him to use. It's available to students. Some of your high schools might have a space like that, some of your high schools won't. And that goes for everything on here, whether that's hand tools, third-party manufacturers, or a machine shop. Different people have access to different resources. So when you're going into this process, you want to think about what you have access to. Maybe you know someone who has access to a makerspace or something like that. Maybe it's not your high school, but it's your best friend's high school. Some of these things like hand tools or 3D printers, maybe you have lying around the house, maybe you don't. A 3D printer also, as you know, these things are becoming a little bit more cheap and more accessible. Sometimes public libraries might have those. So definitely do your research and see what is available to you in your your town where you live, your community. But keep that in mind as you're going to this process, is that some resources might be easier to access for you than for someone halfway across the world. And that is completely fine. Do what works for you, and any of these kind of methods or ways to create a prototype can lead to a successful prototype of any level of fidelity, and that's what really counts. So now we'll talk a little bit about tools and the materials and pitching for this. So I want to preface this by also mentioning that today we're focusing just on physical prototyping in our webinar, so things that you can like see, hold, carry, touch, but also digital prototyping is a huge resource that Conrad students especially, use to demonstrate that their product is viable. And we are going to have a digital prototyping webinar tomorrow, Eastern time, that is. So it'll be December 16th at noon. More information to come at the end of this webinar as well. And then we'll get a little bit more into the nitty-gritty of how to use these digital prototyping softwares to create plans and things like that. But I'll also just kind of a heads up as we're getting into the details of the physical prototyping. A lot of times we will be discussing physical prototypes that were started off as digital prototypes. So for instance, we used a software to create a design and then we 3D printed it, for instance. Yeah.
Yeah, so like to that end, like of what Yamika just said about like using softwares before like getting hands-on, like there are tools out there, like this example, for example, is like Autodesk, that you can use to like do a lot of assembly to put things together and like see like, oh, like maybe you want to test out different gear ratios, or you want to test out like, okay, like what will my thing even look like before you get hands-on and start putting things together. So one thing that I would recommend is like using softwares out there, and like we can talk about some more and you'll learn some more tomorrow if you're at the digital one, is like using them to your advantage, like plan things out before you start like, cutting wood up, start like, putting things together and you're like, oh well, like that didn't work. Now I have to go buy some more wood. Like don't do that. Like use tools online to like plan things out and like test them out before you start putting things together in real life. So like just a quick like overview on like materials that you can use. Like obviously you can use wood, metal, and plastics. Those are like the three common things that people use for like physical prototypes. I think like wood is probably like the easiest thing to work with. And like is most cost effective, I would say, for like most physical prototypes. So yeah, and then like plastics are probably next, and then metal is last. Like metal is like the hardest to like cut and like, do things with. Like you need like fancier um tools to like manipulate and like bend and do things with sheet metal. So I would say like metal is something that you would probably save like if you really wanted to use metal, like for the very end, like once you know exactly what it looks like and you have the right tools. But any of these three can give you a good prototype like once you know what you're doing. So don't feel like, oh, like we need a metal prototype by the end. Like that's by no means like what we're trying to say here. We're just trying to give you an idea of like what maybe you want to start like playing with to begin with, which is like our recommendation would be wood. In terms of like again like going to like towards like different tools that you can use, like hand tools and just like using like things like cardboard and like drills and things like that on wood is probably like the quickest and fastest way to create something that's like simple yet like elegant. And then after that you can get into like 3D printing things, and like with plastic or like outsourcing it to like machine shops and things like that to have it get done. So again, like we'd say like start with like hand tools, then like go to 3D printing, and if you want to go even beyond that and like manufacture like a very like polished product, like that's when you're looking at like machining and outsourcing.
But also, just to add to that, it's really important to be looking at the resources you have available to you. So you want to be thinking about the fidelity of your prototype, the precision you can get to with different ones of these resources. But important things on here also are budget, for instance. So if you have a smaller budget to work with, that's completely fine. And it's not a requirement for the Conrad Challenge to spend a ton of money to get access to machining or outsourcing if you don't have that available to you. A lot of digital softwares are completely free, and a lot of hand tools and materials are easier to come by. And you shouldn't be spending a ton of money to be able to create your prototype. You're all, in high school, and that's definitely not what's expected. But at the same time, we do want to see that your idea is viable and it's something that investors should trust. So now we'll get into some examples of prototyping. On the next two slides, we have some photos of previous year's Conrad teams, and I'll just go over a little bit about what their prototypes looked like at Summit. So obviously the prototype that you have for Summit, it can change if you make it to the Summit round between this January 12th submission deadline and some in April. But these are kind of the best resource or database that we have of some of the teams' prototypes, and these were some of the best ones, obviously, as these teams made it to Summit. So here on the left was a team, and they were working on creating glasses to help the visually impaired. So as you can see, they had on their screen a digital mock-up of the glasses, but then they also had a physical model of those glasses that you can see the student in the middle is holding in his hands. And so at Summit, they had an opportunity for, other participants, judges, alumni to try on these glasses and kind of look through them as well. So that was quite cool. And that was their prototype. That was their physical prototype, was those actual glasses that you could hold and see. The team on the right, their product was basically a machine that would decontaminate airplanes and other methods of public transportation. And so what they did is they created their prototype using, Mom, you can correct me if I'm wrong, but I believe it's the same materials in FRC robotics, right? Yeah, so they created this little robot which did move on its own, well, when they controlled it, obviously. And it didn't actually kind of spray the decontaminating material that they had created, but at the very least, you could kind of get that visual representation of what size of the robot, how does it move, and see like where or how it would work in like an airplane sort of setup or something like that. So that was their prototype that they then brought to Summit. Here we have two other teams from previous years. So the team on the left, oh, I'm blanking. Okay, Umang, what was this? What was their?
Like they were trying to um measure like the armband and the voltage to like basically allow people like control like better motor movement for people with like disabilities.
Okay, yeah. So obviously for something like that where they're working with motor movement, that is a more difficult thing to actually create the prototype of. But as you can see, the student on the left side of the screen, she had the cuff and the like where the electrodes would have been connected. So you could kind of visually see, and that was their prototype that they then used. You could visually see what this product would look like, although it wasn't, you know, fully functional, obviously, and tracking the different like health data, basically. The team on the left, their Conrad Challenge project was cup sleeves that are biodegradable. So this is them working with some of those materials, putting together what it would look like. Yeah, and as you can see, like there's definitely a difference in all of these materials. So you have people using everything from like robots made out of Legos and other components like that to more biodegradable materials. Like you can see the student on the right here with like dirt and some other cardboard looking like biodegradable materials. Yeah. Okay, we'll go into a couple more specifics. So here's an example of a Y maze. So this is not from a Conrad Challenge project. It was actually a project that Umang and I worked on in high school in one of our classes. But we thought it would be a good example to share with you all of what the prototyping process can look like. So for our project, what we wanted to do was create a two-choice chamber, which is this Y maze sort of thing. It's established in other bodies of research. And we were using model organisms to run through it. And it was basically the animal had to make a choice to go either left or right. So we started off with designing this prototype on Onshape, which is one of the digital tools that we'll talk about in our webinar tomorrow. So we created the dimensions, found the angle that we wanted, and we had this kind of layout, as you can see on the left side. And then we went through multiple iterations using different materials, different levels of fidelity. We started off using cardboard to make sure that our dimensions are right, make sure that it would be functional, that it would fit in the enclosure we had. And ultimately what we did is we 3D printed the product in plastic. As you can see on the right, that's what our Y maze looked like. But we did go through the different levels of, you know, starting off with cardboard, using digital tools to supplement and better understand what our project should look like, and then ultimately using a 3D printer, which we had access to at our high school, to create this Y maze that we ultimately used. Oh, is there a slide that I'm missing in here?
Yeah, I think we need to refresh.
Okay, I'll do that really quickly. I have seen some questions in the chat, and we will get to those at the end. As you just saw, there's a Q&A slide in a second. So hold on to your questions, and we'll definitely have time at the end to answer that. Okay, back to the slideshow. Okay.
Yeah. So like this is kind of like this is like another example that we can just like talk about like how we did the prototyping. This is what Yomika and I's like Conrad project prototype was, like well part of it at least. Um and so like I know like right now you're seeing like oh like this like really nice fancy like CAD like online design, but like I think what I want to emphasize is before any of this, there's like a whole period of like sketching and just like trying to figure out what are the different ways that we want this to look like, and just putting those ideas together with like things like cardboard or just like literally just like rolling up pieces of paper. And by doing that, we're able to figure out like the specific details like slowly but surely of like what we want it to look like. Because if you try to jump into like something like this and then just like keep doing 3D printing, like you will waste like a lot of resources, time, and like money in like printing over and over again. So like there's a lot that goes like there's a lot of value in like sketching and then also like taking the time to like figure out like specific like a lot of the details before you do something like you know CADing and printing things out or like wood and things like that. So yeah, so like this is like basically like what we were able to come up with like as a digital version of like what we wanted our like you know prototype to look like after we did lots of rounds of sketching and like thinking about the different measurements and details of what our thing would look like. And then if we go to the next slide, you can see like how this translated into like what we finally like were able to print out. So on the left, you can see like the actual like printing of it happening, and then like on the right, you can see like one of our versions of the prototype, like one of our first versions of like a 3D printed prototype and what it looked like. And this is like also like not even like you know, what our final thing looked like, but this is kind of, you know, how that iteration happened, because like we don't want it to like when you're spending a lot of time doing the 3D printing, things like you don't want it to be like you're still learning from it as much as you should have already learned from the basic stuff before you put in the time and money to like actually 3D print something if you go down that route. But yeah, this is a kind of like, we can get into more questions if you have about it later, but this is kind of like a little example of what Fiona and I did for our project.
Okay,
Yeah,
so
so like
okay, you go.
you can go for it.
Okay, well, that takes us into our Q&A session. So if you have any questions now, I know I saw one in the chat earlier. Feel free to raise your hand, come off mute, or put it in the chat. Whatever is up to you. Let me find the question that I had in the chat from earlier, so we can see if we can answer that one. Okay, so the question we got was, does the prototype need to be a live prototype which can be demonstrated on the spot? For example, if we have a sample of what our prototype already did because it takes multiple days, does that also count? To this question, I would say, for this next round, your prototype will basically be demonstrated, for the most part, it can be in your video. So, it doesn't have to be live necessarily now, although if you are coming to Summit, it would be great to have a live prototype that you can show, but it's not a requirement by any means. If you have a live prototype that you can't transport to Summit, or for whatever reason you aren't able to make it work live, it's okay to have like a sample of something that it did, like a video or something is what I'm assuming. Yeah. Okay, I think that was the only question that I got in the chat. Cool. The recording will be shared also. That was another question in the chat. Okay, and it looks like we have a hand. Jeremy, go ahead. What is your question?
Can you hear me? Can you hear me?
Yes, we can hear you.
Oh, okay. So my question was, because with the project we're working on, it's some of the components necessary to get it to the point we'd want to, a bit, basically they're out of our price scope. So would it be okay to run virtual simulations to show how those specific components would work as a proof of concept, but then for the actual live summit or for the next stage, we only show the little that we're able to put together, resources available to us?
I think I may have missed the last part of that question, but I would say overall, yes, it's completely fine if something you need for your prototype in actuality is out of budget to go with like a virtual rendering of that of some kind. I would definitely recommend coming to the digital prototyping webinar tomorrow. I think that'll be really helpful for you guys and for your team in trying to figure that out. But definitely there is no need to spend a ton of money on a component when you know it's out of budget. Does that answer the question? Yep, just like the comment in the chat from the Conrad Foundation, we do see a lot of teams make it to the finals without having a fully functional prototype. Anything that can demonstrate proof of concept is perfectly good enough and exactly what we would be asking for.
Okay, thank you.
Yeah, of course. We got another question in the chat that was, does the Conrad website talk about the odds or statistics that we make it to the next round? And the answer is no. Every year we have a different number of students submit and a different number of students who kind of move on. So my best advice to you is, if you're interested in coming to Summit this year, to just do your best, not worry too much about the odds, and submit your best effort. And yeah, that is okay. Recommendations on a good video or website. So I'm glad you asked this question. We have a student resources library, and I will share my screen with the link to that as well. So more resources, these are all available on the Conrad Challenge website, so you can find them just by going to conradchallenge.org. But we have a student resources library and also our student guide, which is linked on our challenge website. Definitely check out the student guide. It has all of the requirements for everything that you need to submit for this January 12th deadline in there. On our student resources library, we have an article that talks specifically about how to make a great website, and we have another article that talks about how to make a great innovation stage video. So any other questions that you have about the video or the website, you can get more resources from that there. And hopefully that should be helpful to you all. Ayush, go
Yeah,
ahead.
you
So, are there like videos of previous like contestants and teams that like made their video and turned it into Conrad, so we have like a rough idea of how our video should be?
Yeah, so we don't have any video examples on the Conrad Challenge website per se of specific teams, but if you look on YouTube, a lot of teams will leave their videos online, and you can kind of search up Conrad Challenge and you can find some of those. The challenge guidelines change every year. So every year we ask slightly different things of students. So just make sure that even as you're watching previous year's videos to get an understanding of what other people may have done, that you're still making sure you're adhering to all the guidelines in the student guide and the rubrics that are provided in that document, and you're meeting all the requirements that we're asking of you all this year. Does that help?
Yeah, thank you.
All right, thank you.
any other questions, guys?
Cool. So if you guys have any other questions, feel free to put those into the chat. Definitely if you want to take a photo of this screen, or the student resource library and the student guide, you can also find on the website as well, for more resources. If you still have questions about digital prototyping, I know we kind of briefly touched upon it a little bit. Sign up for our digital prototyping webinar tomorrow. You can do that at this link, tinyurl.com/digital1216. Or you can also send us an email at alumni@conradchallenge.org, and then me, Umang, or one of the other alumni will respond to that and give you our best advice and thoughts on that. We have another question in the chat, so we'll take a moment to respond to that one as well. For physical prototypes, how do you handle expensive failures? Our drone flooded and caught fire in the same week. Oh my goodness, that is really, I'm so sorry about that, Jeremy. That is really difficult to handle. Umang, do you have advice that you would like to share?
Yeah. So I personally did not like we didn't go through this for our Conrad project. Like we didn't have an expensive failure. I did do a lot of robotics, and I can relate to that in that sense. I would say the best thing to do is one, understand why those failures happened, so that they don't happen again. The worst thing that can happen now is it catches on fire a second time. You don't want that to happen. And then again, I would say you want to really take the time to test things. Again, I don't know what the cause for each of these things are, but I would say test each thing in parts. And sometimes when you're just trying to prove that something works, even just showing that two of the more complicated components individually they work, that's a good start before you try to test 4 or 5 things all at once, right? If you try to test 4 or 5 things that you haven't, you're not really sure are going to work, and you do all of it at once, that's going to be expensive. Focus on one small part at a time, and then build upon. Once you know okay, yes, this motor can do this, then try to put the motor with an attachment or a servo, and see if that is going to work, if that makes sense. Do break it down, and then do things in increments instead of doing everything at once. I think that can lead you to not make as much progress as you want to, and continuously burn through a lot of cash, if that makes sense. Yeah, let me know if you have a follow-up question based on my response.
We got another question in the chat asking if all winners had a fully working prototype, and the answer is no. A lot of these teams, as we kind of talked about some of the examples earlier on in the slideshow, are trying to tackle really big and difficult problems. And so we're just wanting to see that your project is somewhat viable. You have a proof of concept, if that kind of makes sense. But no, it does not need to be fully working. It just needs to show that your idea could be real.
Like, I will add to that though, like just because like, you know, we're saying that like everyone like knows prototype doesn't work and stuff, like that doesn't mean that like for lack of a better word, like don't put in the effort to make it work, because like it's still like we still understand, you know, um what is possible based on your ideas, such like what we can still like expect kind of somewhat. And like if we just kind of see that like you guys didn't really try, then like that also doesn't look good. So if there's something that you can achieve, or there's like a smaller part of like the bigger prototype that you can definitely like demonstrate, and like seeing that would be really nice for the judges. So you should definitely put a lot of thought and effort into your prototypes, you know, to as much as you can. How did you personally approach the video and website? I think again we'll talk more about this tomorrow. For like, I guess I'm not really sure like what you mean by approach. When we competed, we didn't have to do a website, if I remember correctly. So the website is new, but like what we like would say for like just general tips right now, like for the video and the website, like you just want to make sure that like someone that watches it like can understand like mainly two things, like what is it that you're trying to like solve or do, and then two, like how is it that like your solution is doing that, slash like why is it that your solution is going to work. So when you spend like your time on like this video specifically, and then you like are showing off your prototype and stuff, like you don't want to like bore them with like too many technical details and like all of that. Like you have space to do that in like other areas of your submission. What you really want to do is like put together some kind of demonstration that convinces someone that watches like, hey, this is a really good idea and I see why it would work, or like I see it working and like they know what they're doing. Like that's what you want someone to come away from it. So like if you are gonna like, you know, maybe like demonstrate something or demonstrate a physical product, or even if you decide to do digital, if you're trying to do a demonstration of it in your video, like that demonstration should be like effective. So just think about like what would like make you want to watch that video and be like, wow, like that's a really cool idea, or like, yes, this, I'm convinced this is gonna work. If you're answering those two questions, then like an investor or a judge or whoever is watching your video will also feel the same way, and that will help you.
And again, going off of that, in the student resources library, we do have articles that kind of talk you through how to start and follow through with both the video and the website. I think kind of like Umang said, the general gist of it is that you want to balance having something that is informational, but also not like boring. Like there should be there should be a reason that someone wants to keep watching. We got a couple other questions into the chat. So someone asked, how does the patent portion work, and can we keep some parts of our project confidential so as to prevent others from copying it? Let me pull up the student guide just to explain a little bit more about that. But I will say, it kind of, again, it really depends on the idea. Different things have different intellectual property components of them, and it depends on your category and your specific case. So make, you know, your best judgments based on that. Yeah. For this next round, I don't believe there is a patent submission required. Yeah, and I'm checking the student guide and that information is correct. So you don't have to worry about the patent portion of your project for this January 12th deadline. And there will be more information provided to students who make it to that fourth round on what is going to be asked of them patent wise. And what was the second half of this question? And in terms of keeping parts of your project confidential to prevent others from copying it, I would say again, just make a judgment call based on how based on your specific project and category, but make sure that you're not hurting yourself in the process. You want to prove to these judges that your idea is viable. Yep, so that is correct. Only the finalists are required to apply for a patent. Another website question, should our website be more visually appealing or factual? I would say if you can do both, that is the ultimate, that's the ideal goal of it. So like it mentions in the student guide, your website should talk about your team, your innovation, and the impact you're going to have. But while it is inherently factual, it has to have all those facts. You want it to be visually appealing. And our article in our student resources library also goes over this. It goes over the different things to keep in mind to make sure that your website is entertaining and fun to look at. Okay, we had another couple of questions in the chat. Okay, so can we do a video where we're not physically together in one video and we take turns talking? That's a great question. Umang, would you like to answer that?
Sure. So Bianca and I competed while like COVID was a thing, so that's definitely like what we did. So it's definitely like totally doable, especially since like we also encourage like when you form teams from like different areas and things like that. And so nothing wrong with like doing a video where you guys are all together and you have like one person talking one part and then another person talking about another thing, and you put those two videos together. The important thing in the video is really just like making sure you're hitting all the points, and then that like you know, we're able to like see your prototype / like understand like why your idea is going to work and how it works. So as long as you're able to like get all of that, like it doesn't really matter if you have a Zoom like, you know, thing going on where that's how you're like having everyone record and put together, or if everyone like records on their phones and then you put it together in a software, or how you do that. But again, I think like someone's going to talk more about that in the future as well.
Yep. And then can the website be one long single page scroll, or does it have to have multiple pages? Again, it really depends. I would say it can be either. Sometimes multiple pages are nice, but it depends on like the website tool that you're using and how comfortable you are with using it. Again, our article on the, I'll just link it into the chat actually, the Student Resources Library article on the website. But that really goes over a lot of these questions on the website. And as long as
So
you're getting all the information, it's okay to have like different formats, or it's okay for different teams to have websites that look a little different from each other. So the link that we just put in the chat is how to build a website, and that should answer some of those questions.
I see two more questions. So one question was, when measuring your project's impact, should you measure it using your ideal design or what your current best prototype can achieve? I think you should address both. I think you should say like, you know, currently this is what we're able to accomplish with this prototype that you see here, blah, blah, blah. But like, you know, with our, you know, hopes to like with money, with funding, like we plan to build and scale and like do this, then we can impact, you know, X, Y, Z, like huge numbers. Cause like, I think it's like important to showcase that like you're already at this, or like with, you know, your limited resources, you've been able to accomplish this, but by like, you know, with funding from investors or by like, you know, applying for grants or whatever you talk about, like you'll be able to do all of this. And this is why you're like like you're solving a really big problem, if that makes sense. Like you shouldn't not address either one. Yeah. And then the next question is like, when a team is selected into the final round and one or two other of our members are not able to attend, can we still present? Like most probably yes, but also like you shouldn't really worry about that right now. I would focus on like the stuff that is for this round, and then like when and if you make it to the final round, like the, you know, Conrad Challenge team and like everyone involved will help like make it possible for you and your team to be able to compete. And if there's for some reason like you can't, like there'll be like some kind of other arrangement made. But like yeah, like they mentioned, like at least 2 members must be present if you become a finalist. So that is a requirement for that.
There were a couple other questions that I got into the chat. So on the patentable technology, the question was, will the videos be shown to the public or other competitors, or are they only shown to other judges? And the answer to that is, for this next round, your videos will only be accessible to other judges. You'll upload them into the portal. A lot of times students will put like an unlisted YouTube video link into their submission, which means that you can only have access to the video if you have access to that link. And obviously after the round 3 submission has closed and you get your results back, and hopefully get your invitations to Summit, then you are completely free to obviously take the video off of the web. But it will not be shown to other competitors or the public without your consent. It's really up to how you customize your video settings. Another question was, can you have graphics or video editing in the video? And the answer is yes, absolutely. Definitely feel free to use any graphics or video editing tools in your video that help communicate your how your innovation works, and kind of proving that it is viable. Another question that we had was, is having more team members an advantage? I would say it really doesn't need to be. It's not an advantage or a disadvantage. You just want to make sure that your team works well together and that you guys have a good team dynamic. We have teams every year that are at Summit with 2 team members, and we have teams that have 5 team members, and all teams have, you know, anywhere between 2 to 5. So Mia, who's on here, she's also one of our alumni. Her Conrad Challenge team was 2 members. My team had 3 members, and it really doesn't matter how many people there are, because we're just grading you, I guess, or scoring your idea based on the idea itself. Another question we got was, at Summit, can international teammates present virtually? And if only US teammates can present, can we record the international teammates speaking on the video and show at the Summit? So I've seen teams in the past have some video components to their for their teammates who aren't able to attend Summit in session or in person. But again, this really is very dependent on the teams itself. So I would say, if you find yourself in the situation, you know, come Summit time, definitely communicate with the Conrad Challenge staff. Feel free to email any of those info or alumni email addresses that we've kind of shared with you all. And it will definitely be like, it basically, essentially, it's a case-by-case basis. Okay, so it seems like we're now getting a bunch of Summit questions, which we know you guys are all super, super excited about. Do we have any other questions on prototyping, specifically physical prototyping? Because there will be more opportunities as well tomorrow to talk about digital prototyping. If you have any more prototyping questions. Okay, the question was, will the judges be playing with our physical prototype? So obviously in the round 3 submissions, that is all virtual, so the judges will not have access to your physical prototype. At Summit, it's really up to you. If you would like the judges to work physically with your prototype, or you want to give them the opportunity, you are free to. If it's more delicate and you want to say, you know, hands off, that is also completely up to you. But other than that, I think we're pretty much ready to wrap up. If before you all head out, you could please fill out this form to let us know how we did on this webinar, hosting it. Please, you know, use your phone, scan the QR code, and fill out that form. We would really, really, really appreciate it. And we hope to see many of you tomorrow at our digital prototyping session. So please, if you could, just really quickly scan the QR code, fill out the form, and then you are completely free to head out.